Assalamu alaikum, students. Hope you will be doing well because your exam is ahead. So, I'm going to upload some difficult questions, tricky questions from your different topics. And now, this question is from current and electricity. So, this question, it is said that the electromotive force of power supply 120 volt, it delivers a current of 1.2 ampere to a resistor of resistance 80 ohm and a current of 0.4 ampere to another resistor as shown in the figure. So diagram is in front of you. So in this diagram, this all is mentioned that 120 volt power supply is there, and there is 1.2 ampere current flowing through this resistor and 0.4 ampere current is flowing through this resistor. What is the internal resistance of the power supply? This is the question. So we have to find out this small r. So if I consider that in this circuit, basically my situation of the question is that I have a battery and I have to find out some internal resistance of that battery. So it means I need to use the internal resistance concept, and for that concept I need terminal potential difference, which is equals to E minus IR. Okay, so we all know this thing, that this is basically either I times external resistance is equals to E minus IR, or in other way around we can have the concept of EMF is equals to I into small r plus capital R. So this all will be used over here. So first of all, I need to find out the total resistance of this circuit. For total resistance, I know that I have a set of information given over here, and that set of information is this one. This will help me out, and when I use this set of information, I probably get the voltages, right? The voltages means the terminal potential difference. So if I say that V is equals to I times R, so V is equals to 1.2 times 80. So 1.2 times 80 will give you the voltages or potential difference across this resistor. 1.2 times 80 is basically equals to 96. So it means that 96 volts are there across this resistor. It means the same 96 volts would be across this resistor, 96 volt. So actually this 96 volt is my output terminal potential. So here I can say that this value is 96 volt. But to reach to this point, I have to calculate the internal resistance. So for internal resistance, I need the total current. So when I say the total current, actually total current can be calculated by this method. You have two currents, 0.4 and 1.2. It means the total current flowing through this battery will be equals to 1.6 ampere. Now I have all the values available, so I can use this equation. E is equals to I times capital R plus I times small r. So this is actually your terminal potential difference. So I can write it V terminal plus I times small r is equals to EMF of the battery. This is calculated. It is 96 volt, where EMF is 120 volt plus I is 1.6, and here is your R. So you can calculate for the R is 120 minus 96 divided by 1.6, so you would get 15 ohm. So the internal resistance of the battery is 15 ohm. So it was a quite easy approach towards this question, and hope it would be very clear to all of you.